Hey everyone, welcome to The Explainer. Today, we are completely demystifying business analytics and big data. We're literally diving into the invisible data forces that shape our daily lives. Everything from those highly targeted ads you see on social media to the dynamically changing prices you end up paying for your airline tickets. So, let's kick things off with something you've probably asked yourself at some point. How exactly does Amazon know what you want before you even do? How do they recommend your next favorite book with such eerie accuracy? Or think about the airlines. How are they using massive amounts of past purchase data to dynamically shift your ticket price from 1 hour to the next, just based on predicted demand? I mean, it almost feels like magic, right? But honestly, it's just pure mathematics. To figure out how they pull this off, we're going on a little data to decision journey today. We'll decode business analytics, break down the three main analytic types, get a grip on big data, look at some real-world practice, and wrap up with the ethics of data. Let's get right into it. Section 1. Decoding business analytics. Moving from gut instinct to data-driven insight. Business analytics definitely isn't just some gut feeling or a lucky guess. It is actually a scientific process. It's all about transforming raw data into real insights so we can make significantly better decisions. Basically, we're throwing out those old simple rules of thumb and using cold, hard data to lead with total certainty. And whether you realize it or not, we actually all use a 5-step decision-making process. First up, you have to identify and define the problem. If you don't know exactly what you're trying to solve, data won't help you at all. From there, you determine your criteria, map out your alternatives, evaluate them, and finally make your choice. Analytics basically swoops in to supercharge this entire workflow. Moving right along to Section 2, the three analytic types, which really serve as the engine of decision-making. Okay, so analytics usually falls into one of three buckets. First, we have descriptive analytics. This is like looking in the rearview mirror, answering what happened, using things like data dashboards and reports. Then there's predictive analytics. This is looking forward through the windshield, answering what will happen through something like sales forecasting. And finally, we have prescriptive analytics. This is the big one, the most advanced type. It answers what should we do by handing you optimized solutions, like figuring out the absolute best way to design a global supply network. Now, I really want to draw a hard line between those last two, because honestly, they get mixed up all the time. Here's the deal. Predictive models just give you a forecast of the future based on past data, but prescriptive analytics, that actually takes that forecast, combines it with a rule, and hands you a specific, actionable decision. So let's say predictive analytics estimates there's a 60% chance someone defaults on a loan. Prescriptive analytics takes that forecast and applies a hard rule, like if risk is over 50%, completely deny the loan. It literally tells you exactly what course of action to take. And as companies evolve, you see them shift their focus, moving far away from basic, standard reporting as they push forward through data mining into predictive modeling, and eventually all the way to optimization and decision analysis. They unlock a massive competitive advantage. Getting that edge? That is the absolute ultimate goal of advanced prescriptive analytics. All right, Section 3, understanding big data. This is the raw fuel for that analytics engine. So, to actually run these advanced models, you need a staggering amount of information. IBM brilliantly defines this with the 4 V's. Let's fire through them. First is volume. We are talking terabytes, even exabytes of data. It is huge. Second is velocity. This is real-time speed. Think streaming data or milliseconds between financial stock trades. Third is variety. Data isn't just sitting in neat little rows and columns anymore. It's unstructured text, it's audio, it's video files. And fourth is veracity, which is all about dealing with the uncertainty and missing values in that data. Honestly, managing all 4 of these dimensions requires incredibly specialized distributed processing environments, like Hadoop, just to make sense of the whole shebang. Let's take all this from theory into reality with Section 4, Analytics in Practice. First up, let's look at the massive grocery chain Kroger. They crunch years of loyalty card data to send out 11 million direct mailers every single quarter. But here's the absolute genius part. Each mailer contains 12 uniquely tailored coupons handpicked for that specific household based on their exact shopping habits. The result? A mind-blowing 70% of households redeem at least one coupon, pulling in an estimated $10 billion in revenue. Talk about predictive analytics literally turning into profit. Next, let's jump over to Disney. Their Magic Band uses real-time location data to completely personalize your theme park experience. These bands transmit data over 40 feet in real time, constantly tracking exactly where visitors are in the park. This lets them do some pretty wild stuff, like triggering personalized character greetings, letting you skip the checkout line by linking straight to your credit card, and creating totally seamless payments. It's this fascinating contrast, right? You have the carefree magic of a theme park on the surface, but it's completely powered by intense, continuous data collection running entirely in the background. Meanwhile, over in the heavy industrial sector, General Electric is gathering 50 million pieces of data every single day. They are monitoring 10 million sensors on everything from medical equipment to aircraft engines. This is the Internet of Things in full swing. By grabbing this data every time a plane takes off and lands, GE's predictive models can actually forecast when aircraft maintenance is needed way before a part ever breaks down. That means zero unplanned downtime. They even use this data to optimize flight paths, drastically decreasing fuel costs for the airlines, a real game changer. But all of this immense power brings us to our final stop, Section 5, the ethics of data. Because with great power comes incredible responsibility. $3.86 million. According to IBM, that is the staggering average cost of a data breach. Just let that sink in for a second. It really highlights the sheer financial and reputational nightmare companies face when hackers get their hands on highly confidential customer information. Protecting this data? It's not just an IT problem anymore. It is a fundamental ethical obligation that businesses owe to the people they serve. And look, ethics go way beyond just cybersecurity. Author Kathy O'Neill coined this brilliant term, weapons of math destruction, to remind us that algorithms and models can actually be unintentionally biased. For example, if a model improperly uses an applicant's home location or zip code to figure out credit risk, it might inadvertently discriminate based on income or ethnicity, even if literally no one intended it to. Data analysts have a remarkably strict duty to catch this and stop bias from infecting their mathematical models. On top of that, researchers are sounding the alarm on severe, unintended consequences with machine learning. Think about it. When social media algorithms are built purely to maximize a user's viewing time, they can completely accidentally start recommending more extreme content and outright false information. The machine doesn't know it's spreading misinformation, it just figured out that controversy keeps your eyeballs glued to the screen. It is blindly optimizing for engagement, and well, that opens up a massive ethical can of worms. Because the stakes are so incredibly high, governments have finally started stepping in. We're seeing strict data privacy laws now, like the GDPR in the European Union, which actually mandate transparent consent. This legally guarantees your right to be forgotten. That means you have the ultimate power to tell a company, hey, erase my personal digital footprint from your servers entirely. Pretty powerful stuff. So, we've walked through the mechanics, the real-world applications, and the incredibly vital ethical boundaries of business analytics. And now, I want to leave you with a challenge. Could you collect real data for a small case study of your own, run these forecasted approaches, and propose the best path forward? As you go about your day-to-day, look at those targeted ads, notice the dynamic pricing, and think about the invisible forces at play. What exactly is the data predicting for you? Thanks so much for joining me on this explainer, and keep questioning the data.